Hello and welcome. Good evening to everyone from India and good morning to Professor Graham Harman. My name is Sukhendu Das and I'm speaking on behalf of Entanglements, Journal of Post-Humanities and Indian Post-Humanities Collective. It's a pleasure and an honor to introduce our distinguished speaker, Professor Graham Harman. Professor Harman does not need any introduction. People doing philosophy around the world knows his teacher very well. However, as part of formality, I'm going to introduce him to our speaker very briefly. Professor Harman is a philosopher and distinguished professor of philosophy at the Southern California Institute of Architecture in Los Angeles. He is highly influential philosophers and most original thinkers of our time. He was named by the Art Review magazine as one of the 100 most influential figures in international art world, and in 2016 was named by the best schools to their alphabetical list of the 50 most influential living philosophers. He is also a key figure in the contemporary speculative realism movement in philosophy and known for his development of object-oriented ontology. He has so far written more than 24 monographs, many edited volumes, and numerous research articles. Some of his monographs include Prince of Networks, Bruno Latour, and Metaphysics, published in 2009, Bruno Latour, Reassembling the Political, published in 2014, Immaterialism, Objects and Social Theory, published in 2016, Object-Oriented Ontology, and Architecture and Objects, published in 2022. Tonight, he is going to preview his forthcoming book, Waves and Stones on the Ultimate Nature of Reality, which is scheduled to be published this November. The question of reality is a baffling one and one of the most fundamental questions in philosophy since its inception in general. Let us hear a new exploration of our conception of reality by one of the world's most influential philosophers. And I welcome Professor Graham Harman again. Professor Harman, the entire platform is now all yours.
The real book. This is an advanced copy I've received.
Oh, that's wonderful.
It's going to officially be published on Thursday, November 6th. It will be only, I think, in hardcover for the first year, although there will also be an audiobook. For the first time in my life, they had me record an audiobook, which was a wonderful experience. I went to a recording studio here in Los Angeles. It took about 3 or 4 days, and then an extra day to go back and do corrections. And I gained a deepened respect for voice actors and people who do that kind of work, because it's very hard to go even a couple of pages without making a mistake or having to go back and say something again. And so people who can do that for a living are very impressive, and I'm glad they gave me a chance to do it myself for this book. Waves and Stones is a title that refers to the opposition between the continuous and the discrete. And it looks backwards on my screen, but it says Waves and Stones. Let me start with contemporary physics, and then we'll backtrack. As many of you know, for more than a century, state-of-the-art physics has had the issue that it is based on two pillars which are ultimately incompatible. And those two pillars are quantum theory and general relativity. It's a good rule of thumb because quantum theory is easiest to see at the level of fundamental particles, and general relativity is easier to see on the level of very large things such as black holes, stars, travel at close to light speed. But ultimately, that is not really correct, because you can also see quantum effects at the level of macroscopic and large objects, and you can also detect general relativity acting at the very, very small level. So really what the difference is between the two is that quantum theory conceives of nature as being discontinuous, is made of tiny chunks, and certain paradoxes result from viewing nature in that way. Whereas general relativity has to do with continuous change, the way that space-time is bent by mass for Einstein in a way that was not true for Newton. And so really the dispute between the continuous and the discrete is at the heart of the discrepancy in the last century of physics between those two pillars on which it is based. I'll get back to that in a little while. Another field where this is especially prominent is in the debates over evolutionary biology. Whether evolution in the animal kingdom was something that happened gradually over billions of years, or whether it's something that happens with relative suddenness. The classical Darwinian view, supported of course by people like Richard Dawkins and by neo-Darwinism more generally, is the idea that big fish eats little fish and big fish has big baby fish. They're gradually getting bigger, and over time you should be seeing a gradual change in species as they adapt to their environment. Well, the problem is that this has never really matched the fossil record. The fossil record does not really show us gradual incremental change of this sort. Instead, we tend to see animal species appear and disappear with relative suddenness in the fossil record. And then you have certain animals like sharks, which are still with us, which have been around in more or less the same form for hundreds of millions of years. They have not been gradually evolving in the way that Darwin's theory suggested. And there have been at least two proposals for new theories of evolution that account for that. One of them, beginning in the early 1970s, was that of the late Stephen Jay Gould and Niles Eldredge, who invented a theory they called punctuated equilibrium. The idea that evolution will happen very suddenly, then you will reach an equilibrium. It stays that way for a while, and then somehow things change. You have a very sudden change in a species, and then it stabilizes and doesn't change very much at all. Ultimately, Eldredge and Gould based their theory on the theory of speciation developed by the German biologist Ernst Mayr, who lived for a very long time, over 100 years. Died, I believe, in the early 21st century. Ernst Mayr, according to Mayr, what happens is a portion of a species becomes geographically isolated from its ancestral species. So let's say part of a species gets stuck on a piece of land that becomes an island for some reason, because of a flood, let's say, permanently becomes an island. So this species is now isolated from the larger part of the ancestral species, and it's facing new environmental pressures in its new environment. And for this reason, it has to evolve rather quickly. And because of this, it reasonably quickly, in geological terms, becomes a new species that can no longer mate with the ancestral species. And perhaps over time, the geography changes and it can spread back to its original lands and maybe even dominate its former ancestral species and become the primary one. There are some documented cases of this. Nancy Knowlton, marine biologist, and her colleagues studied snapping shrimp near the Isthmus of Panama. North and South America have only been connected for 2 or 3 million years. Previously, they were disconnected before they collided into each other and met at what is now the Isthmus of Panama. When that happens, the shrimp on the two sides of Panama became geographically isolated for the first time. So you had one side in the Gulf of Mexico and another group of shrimp in the Pacific Ocean. They did experiments where they brought these shrimp together, and the shrimp still look more or less alike, is my understanding. And when you bring a male and a female together from the two sides, you would expect courtship and mating rituals to happen, because that's usually what happens with these shrimp. Instead, it was discovered that these shrimp begin to snap at each other violently. Far from being potential mating partners, they are potential enemies. And so a couple of years of geographical isolation was all that it took for these species to evolve in different ways so that they are not really the same species anymore, even though they look very similar. And so these two kinds of shrimp are now regarded as separate species. There's another example involving the spotted owl. It turns out there are 3 kinds of spotted owl, the bird. There's the northern spotted owl, which is in Canada, in Washington State, Oregon, down into maybe the far northern part of California. And then in the south, you have the Mexican spotted owl, which is in Mexico up into the southwestern United States. And then in Northern California, you have this third species, which I believe is called the California spotted owl, which is distinct from those other two. And it turns out that Northern California has certain features of geographical isolation that makes it difficult for the other species of owl to spread into that region. But some of them did, and that became the California spotted owl. So you have there another example of a formation of presumably an original spotted owl ancestral species that split into 3 kinds because of geographical isolation. So that's Eldridge and Gould's theory of how evolution happens suddenly. And then there's the even more dramatic theory of Lynn Margulis, great evolutionary biologist who died, I don't know, maybe 14 or 15 years ago now. And she is the theorist of serial endosymbiosis. Her idea is that evolution happens suddenly because evolution happens when two previously separate species actually merge and become the same physical species. And you might ask how this can happen. Well, this can happen easily in the case of viruses. A virus can enter a cell and effectively become part of that cell because it reproduces along with the cell. And after a certain amount of time, it becomes just like another part of the cell. But the cell, because it has the virus, now has new abilities that it didn't have previously. Margulis's great early intellectual triumph is that even as a graduate student at the University of Chicago in the late 1960s, she predicted this. She predicted that what we call eukaryotic cells, which are different from prokaryotic cells, because eukaryotic cells, which all of our human bodily cells are, have organelles in them, different parts. They have a nucleus. And Margulis's early research question as a graduate student was, how did eukaryotic cells form? And her theory was the reason they have all these separate organelles is because some of these organelles, at least, came from outside. They were originally not part of the cell. They were alien species that were incorporated into the cell and actually formed a new kind of living creature as a result of that symbiosis between them. And of course, back in the late 1960s, when she proposed this, there was no good way to test this because there was not yet any way of testing the DNA of cells. But she predicted, even back then, that if we ever get to the point of testing the DNA of cells, we will find that the DNA has no code for many of the organelles in a cell because they're not meant to be there. It's not the DNA that is generating those organelles. The organelles are actually foreign bodies that came from the outside. Well, this first became possible to test in the 1980s with advanced DNA testing, and it turned out she was right. And so today, her theory, which was ridiculed when she was in graduate school, is now a standard part of textbook biology. But the point being, this offers another possible mechanism for how evolution could happen very suddenly, instead of in the slow, gradual Darwinian manner. It could happen by things coming together. I wrote a book that some of you may know called Immaterialism, Objects in Social Theory, that was published in 2016, where I talked about the Dutch East India Company. And I used that term, I borrowed the term symbiosis from Margulis. And what I wanted to show there was that even though you can say the Dutch East India Company existed from, I think it was 1600 or 1601 when it was founded, all the way up to the 1790s when it was officially dissolved, yes. But there were also certain irreversible changes that I call symbioses in the book, where the Dutch East India Company united with some object out of it that then became a permanent part of it and led. So I've given the two examples of physics and evolutionary biology as an example where there's a dispute between the continuous and the discrete. But it turns out this particular discrepancy, this conflict, happens in almost every field you look, which is the clearest sign that it's a philosophical problem. It's a deeper philosophical problem and not a problem specific to any particular discipline. And I'd been wondering about this for years. And I always wanted to read a book about this, and it turns out that such a book does not exist, as far as I could determine, so I decided I had to write it myself. I proposed it to Penguin. This often happens with me. I often end up writing books that I would like to read, but they don't exist, and so I have to be the one to write it myself. And this book in particular took quite a long time to write. I like to write books quickly. This one took maybe 4 years to write. There was COVID, there were some other issues, but also there was simply a lot of research to do. This was a bear in terms of research, this particular book. So it's a good feeling to finally have it done. But let me back up for a second and talk about the difference between the continuous and the discrete in more general terms and define them. Continuum is something that can be defined as a single undivided stretch that can be cut up however we want without having any definite number of parts to it. So the classic example of this would be the number line. If you look at the number line between, say, 0 and 100, how many numbers are there between 0 and 100? Well, you could say 100. You could count by integers 1, 2, 3, 4, 5, 6. But you could also count by halves. I could say half, 1, 1.5, 2, 2.5. I could count by tenths. I could count by hundredths. I can count by any increment I want, and it can always get smaller. So there are effectively an infinite number of numbers between 0 and 100. This is what makes it a continuum. Also, as far as we know for now, time and space are continua as well. The jury is still out in advanced physics, but traditionally, time and space have been viewed as continua. So, how many instants of time are there in this lecture? No definite number of instants. You can cut it up however you want. Henri Bergson, the great French philosopher of the 20th century, made his whole career in talking about how time is not cinematic. It's not made up of frames of time. Time is simply an unbroken flow. Actually, Aristotle said something similar or the same about time back in his physics. But it has often been the case that time has been viewed as a continuum where you can divide it up into as many pieces as you please. And space the same way. How many pieces of space are here in this room? No specific number of pieces. Right? I can divide my room up into 4 parts or 100 parts or 1,000,000 parts, any number I want. It's completely arbitrary because the room is a single block of space and I cut it up however I want. But let's ask a different sort of question now. Let's ask how many people are here in this room, this lecture room, virtual lecture room. I don't actually know how many it is, but it's some definite number. We could not say there's just an arbitrary number of people here and we can cut them up into 2 or 100 or 5,000. No, there's a definite number of people here. So that is what we would call the realm of the discrete. There is a definite number of people here. We just have to count it correctly. It's not a continuum. Some philosophers have tried to push it all the way and say that's a continuum too, and it's just the human mind that arbitrarily decides that there are certain... I would not go with that, and neither would Aristotle. And let's talk about Aristotle, for example, because whenever you get this discrepancy between the continuous and the discrete, the first thing people want to do is choose one of them as being more fundamental than the other and reduce it to everything else. Reduce everything else to it. So, for instance, it's very fashionable these days, particularly in continental philosophy, to say that everything's a single whole, everything's in flux, everything's moving all the time, and somehow individual entities are an arbitrary fabrication of the human mind. So what is happening in a case like that is that people are saying, well, there seem to be discrete entities, but there really aren't. Really, in fact, everything's a single whole, and the human mind is simply arbitrarily cutting it up into pieces that aren't really there. Well, the problem with that theory is then if everything's a whole, then how is the human mind different enough from this whole to be able to arbitrarily cut things into pieces? So those people who say that are at least starting with 2 different things. They're starting with the mind and then the world, and then the mind cuts the world how it wants. There are some examples of this. Thomas Nail is a very prolific contemporary American philosopher who likes to talk about everything as being in motion. Jane Bennett is another very important contemporary author who says that the world is a single throbbing whole or flux, and the mind is simply cutting it into pieces by considering certain temporary swirls to count as individual entities. So that's one way you could do it. You could reduce everything. You could reduce everything that's a discrete individual down to this giant throbbing flux. And in a way, that's where ancient Greek philosophy got part of its starts. In some of the pre-Socratic philosophers of ancient Greece, you have this idea of the apeiron, the limitless or the boundless. This idea that everything is one, and that something happened to break the one into individual pieces. And then, of course, in Asian philosophies, you have so many theories in which the universe is primarily one, and any particular configuration of individuals is derivative of that one. So this is one possible way of looking at the world. Another possible way of looking at the world is the opposite one, which is to say that really everything is discrete. And I can think of actually 2 examples of this. The first one is the kind of philosophy we call occasionalism that began in medieval Islamic thought with a man named al-Ash'ari in southern Baghdad in Basra in the early 9th century, who believed that no 2 things can interact with each other. Only God enables 2 things to interact. So if fire is burning cotton, or fire seems to burn cotton, it's actually God burning cotton. It looks like the fire is close to the cotton and that the fire is causally powerful enough to make the cotton burn. But in fact, the fire being close to the cotton is simply the occasion for God to make a fire happen. It's God doing everything directly. And not only that, but for al-Ash'ari, it was also the case that 2 moments of time cannot connect with each other. Time is not an unbroken flow, as it is for Bergson or Aristotle. Time instead does consist of a series of instants, so that the universe is vanishing every instant and has to be recreated by God in every instant. What's interesting is that this theory, which was associated with a very very conservative form of religiosity because it was associated with the idea of God's absolute will. So if I stab somebody and murder them, it turns out that in fact it's not me, it's God, because God is the only causal agent. So then the question arises of how could God send me to hell if I'm not personally responsible for stabbing the person? And this is a very, very right-wing form of medieval Islam that said it's God's will and we cannot question it. Um, Partly, perhaps largely for this reason, occasionalism did not spread into medieval Christianity in Europe, where there were concerns about free will and the importance of free will. Instead, it took until 17th century early modern European philosophy with René Descartes and his admirer Nicolas Malebranche, who viewed the world as made of two kinds of finite substances, mind and body. Well, we understand how a body can touch a body. We understand how a mind can talk to a mind. But it was problematic for these early modern European philosophers. How can a mind communicate with a body? How can I decide to move my arm and then actually raise my arm, since my mind is one kind of substance and my body is another? And so here God became important as the bridge, the medium between mind and body. Interestingly, Descartes did not believe God was needed for body-body interactions because he did not believe physical bodies are separate. Descartes believed that the entire universe was a single physical body. And this allowed him to have a secular philosophy of nature, where he could simply calculate the way that things move when they press against each other without having divine intervention need to come into physics. So this helped pave the way for the scientific revolution in Europe in the 17th century onward. Okay, but I mentioned there was a second example of prioritizing the discrete, and the other one is aspirational, but it's happening today in contemporary physics. Because if you pick up most any contemporary physics book right now, and there's a lot of good ones that the average person can understand, you're going to hear a lot about the search for quantum gravity, which has not succeeded yet. It's a quest. People are trying to find a theory of quantum gravity. And what quantum gravity means is a search for a way to take Einstein's general relativity, and remember, Einstein's general relativity treats space-time as gradually curved by mass. The search for quantum gravity involves an attempt to quantize that theory so that Einstein's theory of gravity would be re-expressed in terms of gradual jumps in gravitational force. And no such theory has succeeded yet. There are many possible candidates. String theory is the most famous. Loop quantum gravity is another. But now we have, in the past couple of years, a new voice in London, Jonathan Oppenheim, who teaches at University College London, who has proposed that that is not going to work, that gravity will always have to remain classical, meaning gravity is not going to be a quantum theory. Gravity is going to be the exception where things happen gradually, and then quantum theory can handle everything else. Now, I can't weigh in on the evidence in the advanced physics. That's not my profession. And so I don't know whether Oppenheim will turn out to be right or not. I know he's at least being taken seriously. But what I try to say in my book is that Aristotle already gives us an early example of a philosopher who believes that both the continuous and the discrete are equally primary, and that both need to be taken seriously as elements of reality. So how does this work? Aristotle wrote a lot of great books, but two of the greatest are the physics and the metaphysics. And as you can tell from the titles, Aristotle's physics is his theory of nature, and it remained the state-of-the-art theory of nature in Western countries from the time of its writing until Galileo and Descartes, say, early 1600s. And the metaphysics, that title is usually said to have come from one of his editors who didn't know what to call these writings of Aristotle that came after the physics. So he called them the metaphysics, which in ancient Greek can mean what's after the physics, but it can also mean what's beyond the physics. And that's what metaphysics has come to mean. It's come to mean a theory of that which is somehow deeper and broader and more encompassing than physics. And for some people, metaphysics means that which is beyond nature. So it's beyond the physical world. So that need not be the case. But that's the usual account of the relation between the two books of Aristotle, the physics and the metaphysics. But then it occurred to me, and I don't know if anyone's ever noticed this before or not, I couldn't find anyone who had, that really Aristotle's physics is all about the continuous, and the metaphysics is all about the discrete. So what does the physics tell us about? The physics tells us about number, which we already know is a continuum, because there's no definite number of numbers between 0 and 100 or 0 and 1,000. You can keep cutting up numbers into tinier and tinier pieces. Space and time, and more about that in a minute. Also motion. for Aristotle. Motion is an extremely important issue for Aristotle, who was not only one of the first great philosophers in Western civilization, but really one of maybe its first great natural scientist, certainly its first great biologist. And so in the physics, he's very concerned to explain how motion happens. And you've got to remember that motion for Aristotle, unlike for modern physics, does not just refer to motion in space. It doesn't just refer to changes in place. Motion for Aristotle refers to any kind of change, including qualitative change. So that's what the physics is all about. Space, time, number, motion. Am I forgetting anything? Those are the four main ones. The metaphysics, by contrast, is about the discrete, things which are discontinuous, and there are two examples, and I've already given you one, and that example is what he calls individual substance. So each of us is a separate person. We wouldn't say that all of us are a single person and then only arbitrarily are we cut up into 45 rather than 48 or rather than 2. No, we are individual discrete things. That's Aristotle's most famous example. The other one, though, which isn't talked about as much, is qualitative change. And so Aristotle's example is, if you imagine a stone in a river that's being worn away by erosion, Aristotle does not think that happens gradually. Aristotle thinks that for a long period of time, nothing changes in the stone, and then finally a chunk breaks off so that the size is different. Or, as Timothy Williamson, a contemporary analytic philosopher, puts it, there is an exact moment when Aristotle became old, right? It's only vague because of our lack of knowledge. We'll never know exactly what the moment was that Aristotle became old, but there was an exact moment. It happened suddenly. And maybe in some cases you can tell that. I noticed when I came back from the summer this year, I went to a faculty meeting, all of my colleagues looked older for the first time. That hadn't happened in previous years. I don't know what changed this year, but suddenly everyone looked older, and I'm sure I did too. But everyone was noticeably a bit older. So a rough summer, I guess, here in Los Angeles. That was the first time that happened. It wasn't a gradual process. Hope they're not watching this or listening to it. So anyway, that is the difference between Aristotle's physics and his metaphysics. And so the first chapter of my book is about that. Let me give one last example from Aristotle before I move on to other chapters of the book, which is that there's a great writer of paradoxes in ancient Greek philosophy you may know of, and that is Zeno of Ilia. Zeno came from southern Italy, a couple of hours' drive south of Naples, where he was the great disciple of a perhaps even more influential ancient Greek philosopher, Parmenides. And Parmenides and Zeno overlapped with Socrates' lifetime. There's a dialogue of Plato called the Parmenides, where the young Socrates, 18 or 19 years old, debates with the elderly Parmenides and the middle-aged Zeno, and it's the only case we see of Socrates actually losing a debate in Plato's dialogues. But Zeno's paradoxes were designed to prove the truth of his teacher Parmenides' philosophy. His teacher Parmenides' philosophy was that, first of all, everything is one. There's no individual things. And second of all, things do not move. And Parmenides and Zeno believed that if you trust reason, you will see that this is true. It's only the senses that teach us that everything is changing all the time and that there are many different things. Really, everything is one and motionless. And Zeno constructed a number of ingenious paradoxes to try to show that this is the case. One of my favorites is, whichever room you're sitting in, imagine that you are trying to walk to the door of the room. Zeno tries to show that this is impossible. And the way he does this is by saying, before I can get from here to the door, I have to obviously go to the point halfway between here and the door. Let's call that point A. So now I go to point A. Now I'm trying to go from point A to the door, but to do that, I have to pass through the halfway point there. So I'm going halfway between point A and the door, which would be point B. So now I'm at point B. Well, now that I'm at point B, in order to get to the door, I first have to pass through point C, which is halfway between point B and the door. And as you can see, you're going to get closer and closer and closer and closer to the door, but you're never actually going to reach the door. You won't be able to move. And Zeno concludes, therefore, motion does not exist. It may look like it exists thanks to your senses, but why would you trust the senses? Your reason is a far more reliable guide, and your reason teaches you, as in the paradox just given, that there's no way to move to the door. Okay, that's one example of one of Zeno's paradoxes. The other one is the race he describes between Achilles, the fast hero of ancient Greece, and a turtle, one of the slowest animals. If you have a race, a foot race between Achilles and the turtle, and the turtle gets a head start, the turtle will always win the race. The turtle cannot be passed. And the proof of that is as follows. Let's give the turtle a certain head start over Achilles. And let's assume, for the sake of argument, that Achilles is exactly 10 times faster than the turtle. Okay, so the race starts. And the first thing is that Achilles has to catch up to where the turtle started before he can pass him. Okay, so Achilles has run to the turtle's starting point, and in that period of time, the turtle will have gone 10% further because the turtle is 10% as fast as Achilles. Okay, so the turtle is still a little bit ahead of Achilles. And now Achilles needs to catch up to where the turtle just went. He does that, the turtle goes another 10% forward. And now Achilles needs to catch up with that. And so the turtle during that time has gone another 10% forward. And so you can see Achilles is going to keep coming closer and closer and closer to the turtle, but is never going to be able to pass him. And therefore the turtle will always win as long as the turtle has a head start. Here again, we know from sense experience that people can pass each other in races or on the sidewalk quite easily. It's not difficult at all. But Zeno would say if you trust your reasoning mind, you will see that this is not really what happens. Nothing actually moves. And then a final example, a final paradox of Zeno that I will mention is the example of an arrow in flight. So let's say an archer fires an arrow at a target. Well, at any given moment of time, the arrow is going to be in a definite position in space. So at any moment of time, the arrow is not moving. And yet, if you look at the time as a whole, the arrow is clearly moving because the arrow flies from the bow all the way to the target. So there's a paradox there for Zeno because how could you have motion constituted out of individual motionless sequences? All right, well, Aristotle, as mentioned, wants to be the philosopher of motion because he's one of the great scientists along with one of the great philosophers. He wants to be able to explain change. And so it is imperative for Aristotle to refute Zeno. The way that Aristotle does this is he distinguishes between the potential and the actual, this famous distinction that is still with us today. And what he means by this is that the path from me to the door, for example, where it was supposedly impossible for me to get to the door, is not actually made of an infinite number of halfway points. It's only made of a potential number of halfway points. It's actually just one motion for me to go from here to the door. To say that it's made up of all these halfway points is something I add later with my mind. This is another way of saying that the interval of space between me and the door is a continuum, just like the number line. There is no definite number of numbers between 0 and 100, and there is no definite number of spatial points between me and the door, which is why Aristotle thinks Zeno's paradoxes don't really work. He's creating halfway points and catch-up points in these paradoxes that don't really exist. And as for the paradox of the arrow, Aristotle simply denies that time is made of instants. So for Aristotle, the arrow is never actually in a single position. The arrow is always in movement, and you can never pin it down to an exact point in time or space because it's always in motion. And as I put it in my book, Aristotle says, for that reason, you can never find the exact point in time when something began because there are no points in time. What was the exact moment in time that you fell in love or that you turned to the dark side? You can never pinpoint either of those with complete accuracy because there is no such point. There's always a kind of vague, continuous stretch where something happened. So much for Aristotle. That's the first chapter of my book. And then in chapter 3, it's actually chapter 2 because chapter 1 is an introductory one. Chapter 2 is Aristotle. And then in chapter 4, I go to Henri Bergson, the great French philosopher of the 20th century, who Bergson is often thought of as very different from Aristotle because Aristotle is thought of as the philosopher of discrete individual substances, whereas Bergson is thought of as the great philosopher of flux and flow. And this is how Gilles Deleuze interprets him. And that's true. That is true of Bergson. But Bergson is also surprisingly aware that we need to be able to account for discrete individual things. He has a way of doing it. But rather than talk about that, I want to talk about the intervening chapter 3, where I go to a different sort of topic, which is human history, where we also find the continuous and the discrete play out in a number of ways. I talk in that chapter at the beginning, chapter 3, about Ibn Khaldun, the great Arab historian of the Middle Ages. Came from North Africa, but spent his maturity in Cairo. And he has sometimes been called the greatest historian who ever lived in any civilization, and that may be true. I mean, there are other great historians, but Ibn Khaldun is certainly on the short list of candidates of great historians. There are basically just two central aspects to his theory. One of them is his theory of generations. Ibn Khaldun's idea is that generations in any given society or institution will always tend to decline. And his reason for that is that whoever founds a dynasty or whoever founds a great business or whoever founds a school of philosophy did so against all odds and with great struggle. And they came from humble beginnings usually, and they realized how much hard work it took to achieve the victory or the success that they achieved. And perhaps the easiest example would be the founder of a political dynasty, because that's what Ibn Khaldun is most concerned with. So consider the early Arabs, who had been impoverished desert dwellers, but then under Islam, they spread very rapidly through a large part of the world and spread the religion and also spread their military power throughout the Middle East very quickly. Well, obviously, Ibn Khaldun has a great respect for this first group of Muslim leaders. And the problem is, he thinks what happens is that once that generation passes, and we could argue about how long a generation it is, Ibn Khaldun gravitates towards 40 years. Others have said 15, such as in Spanish philosophy, but let's go with Ibn Khaldun's 40 years here. You now have the second generation taking over once the first generation passes away. The second generation saw how difficult it was for their elders to start the dynasty or the business or the school of philosophy, realize how much work went into it, realize how fragile a success it was, and are able to speak with these elders, this first generation, and take seriously all the achievements they had. So this second generation is actually still quite hardworking and alert and quite able to preserve what their elders established, sometimes even improve it. The third generation, though, you're starting to get to a group of people that may not personally know the original generation, or maybe they just remember them vaguely from childhood. And the third generation is already somewhat starting to take success for granted. They grew up in a society that was already dominant, or a school of philosophy that was already widespread. And so they simply assume, of course, we will always be on top. We've always been there. And then by the fourth generation, and especially the fifth, Ibn Khaldun thinks the situation becomes truly perilous, because people become spoiled and decadent. People no longer realize how hard it was to reach a position of success, because the elders are now dead, they're gone. And so what you have is you have a bunch of spoiled playboys, or you have people who focus on competition with each other for leadership rather than with enhancing the standing of the group. And so eventually what happens is that this dynasty collapses, because people have become corrupt and greedy weaklings who can no longer defend the group. And usually some outside group will come in and take power. And Ibn Khaldun, as a medieval Arab, points out that leadership of Islam passed rather quickly from the Arabs to other groups, such as the Berbers or the Turks, who were no longer ethnically the same group, even though they were still Muslims. And he thought this was because the Arabs they went into generational decline during that period of time. And he doesn't think that's anything specific to the Arabs. He thinks this happens to anyone who's in power or any group that's on top for more than a couple of generations, that they will become lazy and spoiled, and that they will eventually give way to a stronger outside group that had to work harder. That's one aspect of Ibn Khaldun's theory. So you can see it's a discrete theory of history. Rather than history changing gradually, it happens almost like as with a strobe light of generations. You've got one generation, and then the next, and then the next, and by the fourth, or certainly by the fifth generation, the dynasty is probably going to collapse because people are simply too lazy and decadent and are taking everything for granted. Now, interestingly, the second and related part of his theory has to do with a different sort of conflict between the continuous and the discrete. And this is the conflict between civilization and nomadic herders. And what, as an Arab, what Ibn Khaldun was most concerned with were the Bedouins and the Berbers, these nomadic tribesmen who ride on camels and live in tents in the deserts. And he describes them as being very rapacious and fierce and inclined to plunder the cities they encountered, whereas people in cities tend to become they become more civilized in the sense of being more refined and taking more of an interest in the arts and the sciences, but they also become corrupted by urban luxuries, according to Ibn Khaldun. And so, on the one hand, civilized people, the people who live in cities and have farms to support the cities, people who live in one place, basically, and don't wander around wherever the herds of animals are going, These people, on the one hand, are more refined. On the other hand, they become weaker. They become unable to defend themselves against these wilder tribesmen who are more fierce and have less of a sense of private ownership and are perfectly willing to come in and sack a city and take it over. So that's another difference between the continuous and the discrete, because the nomads are the lords of this continuous wasteland. In the case of Arab civilization, it's the Bedouins and Berbers of the desert. So the desert is this continuous wasteland where the threat comes from. Whereas in cities, you have this fixed, discrete location with walls. That's where civilization happens. Now, the paradox for Ibn Khaldun is that the nomad actually envies civilization. The nomad would like to become civilized. And so even if at first the nomad destroys civilization, sooner or later the nomad also becomes part of civilization and becomes part of the same cycle of generational decline that you saw from the city dwellers in the first place. And of course, the Arabs themselves were originally a nomadic society, Bedouins living in tents, and then became a very highly urbanized civilization, especially under the influence of Islam, when that period of their history happens. That's the kind that he talks about. But there's another even more famous example from history, and that is the Mongols. The Turks as well, but the Turks were an earlier example, and the Turks became sedentary earlier than the Mongols did. The Turks and the Mongols both come originally from the region around Mongolia. At a certain earlier stage, the Turks began their westward movements, becoming very important figures in the history of Persia. The Turks being extremely important in governing the Silk Road, which was so important for human trade between West and East. Until finally the Turks ended up where they are today in Anatolia. Of course, there's Turkic peoples throughout Central Asia, but when we think of the Turks today, we're mostly thinking of Anatolia and the small European parts of the modern nation of Turkey. And so the Turks became a discrete, sedentary urban civilization at an earlier date than the main branch of the Mongols. The Mongol hordes that we think about and that history fears, this peaks in the 13th century, though it was happening for 2,000 years. For 2,000 years, there were successive waves of nomads coming from the north and from the west, falling upon China primarily. And we have physical evidence of this in the Great Wall of China, which was designed and gradually expanded to protect Chinese urban civilization, discrete Chinese civilization, from these threatening nomads who would sweep down from the north and the west. And then eventually, the Mongols would sweep down also on your part of the world, on India, on Persia, on the Middle East, and they could have maybe made it all the way to Egypt, but they were stopped in a battle in the Palestinian lands by the Mamluks of Egypt and were never able to spread into Egypt. But the Mongols were the most terrifying instance of this in human history. Now, what's interesting is that just as Ibn Khaldun said, the Mongols, although originally destroyers of something like Chinese civilization, eventually became great admirers of Chinese civilization. And this is embodied in one person in particular, Kublai Khan, one of the great descendants of Genghis Khan. And Kublai Khan was not only a powerful ruler, he was also absolutely fascinated with Chinese civilization. Despite being a Mongol, he mastered the Chinese language. He loved all aspects of Chinese culture. He engaged in very refined debates with other religions, Muslims, Buddhists, Hindus, Nestorian Christians, about which religion was superior. So this, within a few generations, Kublai Khan descended from extremely fierce and rather barbaric Mongol ancestors, had become a very refined urban Chinese figure. But then, just as Ibn Khaldun predicted, it was only a few more generations after Kublai Khan that the Mongol rulers of China became decadent, pleasure-seeking wastrels, and traditional Chinese civilization rebelled and threw off Mongol dominance and restored traditional Chinese civilization under the Han Dynasty. So this process that Ibn Khaldun talked about in the Arab countries is also visible in the Chinese context. Now, what's interesting is that there is an opposite figure in history to Kublai Khan, the figure of a civilized person who becomes barbaric. And I want to raise an example here in case any of you are familiar with the novels of Jack London. The most famous of Jack London's novels is The Call of the Wild, in which a dog ends up turning into a wolf again. A dog leaves his domestic environment and goes back and joins a wolf pack. But then you've got another book where the opposite happens, White Fang. In White Fang, you have a wild, I don't know if it's a wolf exactly, but wolf-like creature that then becomes a pet. So these are two possible movements you can have. The domestic creature becomes wild and savage, or the savage and wild creature becomes domestic. And I've already mentioned Kublai Khan as a historical example of a wild barbarian who became a pillar of Chinese civilization, introduced paper currency and improved the postal service in China, became a very exemplary member of Chinese civilization. The opposite person would be Timur or Tamerlane, who inflicted many deaths on India as well, as you will know from your own history. Timur was ostensibly the leader of a civilized empire based in what is now Uzbekistan. His capital was Samarkand. He was of Mongol descent, but he was from the period of Mongol urban civilization, later than Genghis Khan's more savage and barbaric phase. Nonetheless, Timur became as big a destroyer of human beings as Genghis Khan ever was. Timur would send his armies repeatedly to annihilate cities in various places. He'd go to Baghdad. I think he destroyed at least twice. He went to Russia 2 or 3 times. He went to Turkey 2 or 3 times. India several times, where he would massacre people by the tens and hundreds of thousands. And so in a way, Timur represents the pole of barbarism on the civilian, which is something that Ibn Khaldun never wrote about. Ibn Khaldun was concerned with the fact that barbarians were tempted by civilization. He didn't talk about the opposite fact, which history shows to be equally true, that the civilian easily becomes barbarous. And I reflected on why that's the case in the book. And really, I think it's fairly simple that the civilian, the defender of civilization, has more to lose than the barbarian. The barbarian doesn't have a fixed living place. They can always move. They can always move their tents 100 miles further into the interior of the country if they are invaded. And so the barbarian doesn't have a lot to lose, and so they can give up anything. They can always rebuild it. But let's say you have a lot of farms and a lot of cities that are yours, that you have spent thousands of years cultivating, and you see a threat to them. Well, quite naturally, you are going to be willing to annihilate whatever seems to pose a threat to your civilization. And in the case of Timur, he wanted to surround himself with a kind of artificial wasteland of destroyed empires so that none of them could pose a threat to his own home capital of Samarkand, one of the great cities of the Middle Ages. Even though the Mongols had already pillaged it, it had been restored by Timur's time. So there's an interesting dialectical movement there, that the barbarian wants to become civilized, and yet somehow the civilian wants to become barbaric. And I don't think I need to give you any examples of the 20th century and the number of barbaric acts committed by some of the most civilized and developed countries in the world. Firebombing cities, concentration camps, atomic bombs, all of these things done in the name of defending a civilization that believed itself to be a threat from some internal or external threat, internal or external force. So that's what I talk about in that chapter of the book. And I see it's about 9:20. Let me just give a quick preview of a couple of the other chapters, and then I'll take your questions. I talk about Thomas Kuhn's theory of scientific revolutions. People keep reading Thomas Kuhn, even though he's been refuted any number of times, and Kuhn's book is now 60 years old. Thomas Kuhn, the American philosopher of science, is the one who coined the phrase paradigm shift, which you would all know, probably even if you don't know Kuhn's own writings. Kuhn grew up, he started as a physicist before he shifted his career to history of science. And what he realized is that he didn't believe the typical history of science of his era, which is the post-World War II era, which tended to see science as happening gradually, much like Darwinian evolution in nature. So a scientist would make a small discovery, and this would incrementally improve the previous science, and this process would go on year after year after year, and then eventually this would lead to larger changes viewed on the scale of centuries. Kuhn thinks this is what should be called normal science. Yes, this is how the average scientist behaves. The average scientist doesn't dream of making a revolutionary discovery, except maybe as some vague professional fantasy of success. But the average scientist, according to Kuhn, simply wants to solve puzzles, anomalies. The average scientist doesn't challenge Einstein's theory of relativity. I mean, the very cutting edge people try to do that. But the average scientific researcher will not be trying to overthrow Einstein on any given day. What they are doing is they're largely accepting Einstein's theory of gravity, and then they are trying to solve certain puzzles that arise from Einstein's theory, because no scientific theory ever solves all the problems it was designed to explain. There are certain measurement discrepancies, or there are things that happen in an experiment that don't quite fit what we see from Einstein's theory. And there's plenty of work to be done in cleaning up those problems. That well over 90% of science, in Kuhn's view, is this sort of normal science, as he calls it. Quite different from this are what he calls the non-cumulative episodes, the non-gradual episodes that we know as scientific revolutions. Kuhn is adamant in saying that these are discontinuous ruptures with the science that came before. So consider the difference between Einstein's theory of gravity and Newton's theory of gravity, which had ruled for 220 some years before that. Newton's theory of gravity was actually the first theory of gravity. Obviously, people knew before Newton that things fall on the ground when you drop them, but Newton was the first to realize that the force that makes something fall to the ground and the force that makes planets revolve around the sun is actually the same force, expressed differently. Now, Kuhn points out that there were over 200, actually this wasn't Kuhn, this was Imre Lakatos, points out that there were over 200 problems with Newton's theory from the start. And so even a theory as great as Newton's never solves all the problems. It took other people trying to work on these things. For example, at first, Newton's theory couldn't explain the motions of the moon. Very big problem. And yet people figured, well, there's got to be a way to explain the moon using Newton, because Newton's theory is so useful on all these other topics, right? Another one is, famously, Newton could not solve the three-body problem. And of course, there's a television show and a book called The Three-Body Problem, named after this. In other words, Newton was able to explain the mutual gravitational attraction of two planets in space, but he couldn't do this for three or more. It turned out the mathematics were so complicated that it took some decades before some other leading mathematicians were able to solve the three-body problem, and so we have it solved today. But there were many other problems that Newton could never explain. And in fact, one of the reasons people believed Einstein's theory was correct in the end is because it solved a problem that Newton's theory could not explain, that Einstein wasn't even trying to solve. And that had to do with the perihelion of Mercury. The point where Mercury is at its closest approach to the sun on its orbit was changing in a way that Newton's theory could not really explain. And yet Einstein's theory, according to which the gravity of the sun is actually warping space, was able to explain this very well, even though Einstein didn't even try to do that. That was just a byproduct of his theory. And this is one of the reasons people finally said, wow, Einstein's theory can solve problems that the earlier theory could not. All right, some of the other major differences, I've already mentioned that for Einstein, gravity is a curvature of space and time, whereas for Newton it's not. For Newton, space and time are flat. They're not curved at all. And another difference is that Newton always assumed, he never quite believed it, but he always assumed that gravity happens at infinite speed. He didn't like this because it sounded miraculous. It sounded like action at a distance, but he said, this is how the theory works. Let's assume gravity happens at infinite speed. Of course, for Einstein, nothing can happen at greater than light speed. And so even gravity can happen only at light speed. So that's another major difference. So you'll often hear people say that Newton's physics is still correct, but Einstein modified it for certain special cases. Kuhn is totally opposed to that view. For Kuhn, there is a radical rupture between Newton's physics and Einstein's physics. And one instance of this, one indication of this, is that for Newton, mass is conserved, right? You cannot create or destroy mass. You can only change it into different kinds of mass. Whereas for Einstein, E equals mc squared, mass can be converted into energy, which is why we have atomic bombs and atomic power. And Kuhn points out that that's completely incompatible. Newton could never possibly have predicted that matter could be converted into energy. This is a completely different theory of physics. And then Kuhn actually pushes it a step further and says it's not just that Newton and Einstein have different theories about the world. He says they actually live in different worlds, in the sense that the scientist is a part of their world and helps create their worlds. And so Einstein's world is actually a different one from Newton's, according to Kuhn. It's not just that they're describing the same world differently. That's a separate question we can debate another time. Maybe two other things I want to talk about very quickly. The next one is my chapter on architecture. I'll do this very briefly. I knew very little about architecture when I went to work at SciArc in 2016. I was brought into the architectural world roughly a decade ago because a number of architects were interested in my philosophy, and I wasn't expecting this either. I think what had happened is that Since the crisis of modern architecture in the 1960s, people couldn't really figure out how to build anymore. Modern architecture was all about constructing buildings in a rational way that made sense and forgetting about the influences of history, just sweeping away history. In the 1960s, you started getting what's now called postmodern architecture, where people started wanting to preserve historical influences on architecture, preserve meaning in architecture. Since that time, architects began turning to a series of philosophers for inspiration. The first was Heidegger. The second was Derrida, peaking in the 1988 Deconstructivism show in New York. And then Deleuze. My interpretation of why object-oriented ontology was drafted by architects is that the Deleuzian wave had run its course of 15 or 20 years, began in the early 90s in architecture, and that around the time people were getting a little tired of Deleuze, O came to be seen as a possible new candidate for a philosophy that can help stimulate architecture. This is when I started being invited to lecture at architecture schools. I now teach at an architecture school, may teach at an architectural school for the rest of my career. We'll see. I like it here. But what I talk about in this chapter of the book is that in the late 1980s, Derrida's influence in architecture was very much at its peak in the Deconstructivism show of 1988. And deconstructivism in architecture is about sudden, disconcerting, and surprising ruptures in architecture. So you might have a crack down the middle of the building that causes disorientation and uneasiness. You might have a typical tall skyscraper that's turned over on its side, so it's horizontal. You might have buildings that take very sudden angles that weren't expected. You might have windows that are not straight up and down, but that are diagonal. Or you might have a pink skyscraper. You're going to have very sudden surprises and disruptions in a way that these architects thought was typical of Derridian philosophy. Then starting in the early 90s, even before it started in philosophy, in philosophy around 1994-95, I started noticing Deleuze was becoming a cooler figure than Derrida. The cool kids, the cutting edge people were starting to turn more towards Deleuze in the mid-90s. Turns out that happened in architecture a few years earlier. That was 92, 93. And what that did in architecture, it entailed a turn towards architectural smoothness, where instead of sudden ruptures and changes of direction, you had curves, flowing walls. You had no right angles on buildings. Zaha Hadid, even though she wasn't explicitly a Deleuzian, the late Zaha Hadid, who died 9 years ago, too young, is called the Queen of the Curves. Her buildings are very flowing. If you go look at her Aliyev building in Baku, Azerbaijan, on Google, it's a wonderful, beautiful, memorable curve of a building. This is in some ways the opposite of deconstructivism in architecture, even though Zaha Hadid had been included in the deconstructivism show. So in that chapter of the book, I talk about that period in the early 90s in architecture when there was a rather sudden shift from Derrida-inspired architecture to Deleuze-inspired architecture. And then I want to just give you, not the concluding chapter, but the second to last chapter, which has turned out to be many people's favorites. This is a chapter on what's called NOMA, N-O-M-A, which stands for non-overlapping magisteria. And what this comes from is a debate between the so-called Four Horsemen of New Atheism on one side and Stephen Jay Gould, the late biologist, on the other. The Four Horsemen of New Atheism, I'm not sure if they're known at all in India, but they're very media-hungry figures in the Western world. These four so-called Horsemen of New Atheism, Sam Harris, Richard Dawkins, Daniel Dennett, and who am I forgetting? Sam Hawkins, Christopher Hitchens. These four people became very severe critics of religion, especially after the September 11th terrorist attacks. They became severe critics not only of Islam, but also of religion in general. And they defended instead a fairly hardline secular worldview based on science and based on liberal politics, and saw religion in general, the very existence of religion, as a threat to this, as something primitive and superstitious and so forth. The classical Enlightenment approach to religion. The Four Horsemen of New Atheism, somewhat surprisingly, were countered by Stephen Jay Gould, who's been dead now for a quarter century. Stephen Jay Gould defended instead what he called non-overlapping magisteria, which is basically the idea that science gets to tell us what's true about nature, but when it comes to things like the fate of the soul after death, that's something science can tell us nothing about, and therefore religion has every right to provide answers for this. That's Gould's position. Now, of course, the Four Horsemen are appalled by this, even to this day, even though Gould has been dead for 24 years. Richard Dawkins, who's still alive, calls this cowardly and flabby and says we always need to take scientific evidence as the standard over religion. And Dawkins makes an interesting point, which is that you can't just say these two exist side by side because they do come in conflict sometimes. And Dawkins imagines, what if we were to find some DNA evidence in a cave in the Middle East that proved that Jesus had no earthly father? Somehow they found the DNA of Jesus somewhere, and it showed there was no father and only a mother. Do you think the Pope of the Catholic Church would say, well, I can't comment on this because that's scientific and religion only talks about the soul? Now, Dawkins is surely right that the Pope would be very excited. The Pope would say, see, this proves that the Catholic religion is the true faith. It has just been scientifically proven that Jesus didn't have an earthly father. He was immaculately conceived by Mary, Mother of God, and so forth. And so Dawkins' point is that you can't neatly arrange these things side by side and have them not interfere. They're always overlapping and always coming into conflict. In fact, Gould admitted that. Let me throw a couple things out here. The late Bruno Latour, my good friend, the French philosopher Latour, who died 3 years ago, wrote this great book in 2012, An Inquiry into the Modes of Existence. And in a sense, Latour was trying to do something similar to Gould there. Latour was trying to show that there are many different modes of existence and they cannot be the judge of the others. Latour's point more specifically is that modern Western civilization is dominated by two criteria of truth, the scientific and the economic. Science usually gets the last word on things, except when it comes to human affairs. Economics has become the human science par excellence, and economists see themselves as making the final decision on things. Latour's response to that is to point out that there are many other different modes that cannot be ruled by science and economics, and his most convincing example is probably law. I think we would all agree that as wonderful as modern natural science is, it cannot have the last word in legal trials. Why not? Well, because legal trials cannot simply be a series of scientific tests. In the United States, back in 1994, we had the shocking double murder case of O.J. Simpson, one of our great athletes, who was accused of murdering his ex-wife and her friend. And quite a bit of DNA evidence pointed to O.J. Simpson being the actual murderer. As you may know, he was found not guilty in his trial, not guilty of murder, even though there was overwhelming DNA evidence. Okay, why is that? Well, because you can always question DNA evidence. You can question whether the police were corrupt and whether they planted some of the evidence at the scene because they wanted O.J. Simpson to be found guilty. You can claim that there was contamination in the laboratory, right? The lab was not properly supervised. You could also claim, as a defense attorney, that yes, this DNA evidence is real, but they didn't give it to us by the deadline, right? The defense did not have enough time. They needed to give us this DNA evidence before October 10th, and they didn't. Therefore, judge, please throw out the evidence. And the judge often will do that, at least in our legal system. And presumably in India as well. There are cases where evidence cannot be used because the prosecution was involved in misconduct. So law shows us a case where science does not have the last word. It has an important but subordinate role. Latour would also say that politics is like this, right? That politics is not the same as law or science, right? Because sometimes a politician is in a position where they might feel like they have to ignore international law. And we all become very shocked and angry about this. But ultimately, no leader of a country is going to sacrifice their country because international law says they should do so, right? The leader of a country is always going to try to increase the survival and the power of their country within certain limits of behavior. But the example I always turn to, since I lived in Egypt for so long, is the conflict between Egypt and its African neighbors over Nile water. What happened was that a treaty was signed between Egypt and Sudan and Ethiopia way back late 1940s about which country would get which percentage of Nile water. What started happening when I moved to Egypt is that countries above Egypt on the Nile, like Sudan and Ethiopia, started taking more water from the Nile than the treaty allowed them to. And Egypt not only objected to this, Egypt at some point was threatening force. For example, Egypt threatened Ethiopia, if you build a dam on the Nile, we're going to attack it. And the response of these sub-Saharan African countries beginning in the 1990s was to increasingly be forceful and say, stop threatening us, stop treating us like children. Egypt's response was, yes, but you signed a treaty. Sudan and Ethiopia said, yes, but we signed that treaty during British colonialism. You can't expect us to be bound to that, right? That wasn't us, that was the British. And then Egypt says, yeah, but we're a desert and you're not a desert. You get rain. You should use the rainwater. And the other country said, Egypt, you're very bad at irrigating. You waste a lot of your Nile water. So improve that first before you complain to us. So it goes back and forth and back and forth. And of course, I was in Egypt. I had many Egyptian friends. And so for that reason, I'm naturally inclined to see the Egyptian side of the story. But I can't really say that Egypt's side of the story is truer or more logical than Sudan's or Ethiopia's, or now South Sudan, a new country, which is another part of this discussion. And incidentally, Egypt opposed the creation of South Sudan for this very reason. They didn't want yet another country to have to argue with about Nile water, but now they have 3 countries to argue with instead of 2. So that's a case where an Egyptian president might simply decide to go to war with those countries in the future, simply because he or she thought that Egyptian survival depended on it. That's political. That's not necessarily legal, because international law might say that Egypt is wrong and they have to give up a certain percentage of water to the other countries, but Egypt might decide politically that it's a matter of life or death for them. And you may know the right-wing political philosopher Carl Schmitt, who this is how he defines sovereignty, right? The sovereign is the one who decides the state of exception, that this is a state of exception. Egypt is under threat. Egypt cannot afford to give up its water, and therefore we must fight, even if international law says that we're wrong. Or Israel-Palestine is the last thing I want to wade into right now, but you can imagine a Schmittian analysis of that situation too. You can imagine all of international law telling Netanyahu, you have to stop bombing now, you're just bombing women and children indiscriminately. And you can imagine Netanyahu making a Schmittian case that the very survival of Israel is at stake unless we teach Gaza, Hamas a lesson, et cetera, et cetera. So there are cases where politics, law, morality all come into conflict, and there's not one highest tribunal you can always go to that's going to satisfy everyone. So that's my second to last chapter in the book. And then in the final chapter, which I won't summarize here, I propose the beginnings of a solution. But this solution requires that both the continuous and the discrete are left as basic elements of reality, and one is not reduced to the other. So thanks. That went longer than I expected. I will now take your questions. Thank you very much.
Thank you, Professor Harman, for this enriching talk, and it's a pleasure and also learning experience listening to your talk. And we wish your talk could go on for a few more hours. And now I open this session to your question, answer, and observation. Whether you could directly ask Professor Harman, and he will be happy to answer your question, or you may type your questions on the chat box.
And I just want to say one thing, and this is opportunistic, but I see that Hakan Atay is in the audience, and I need Hakan to email me because we communicate by Facebook, and I'm shut out of Facebook now. So Hakan, you need to email me at the email address I'll very boldly put here in the chat window. Because we need to talk about my Turkish publication, but I don't know your email address. All right.
Dr. Nikki Young has a question in the chat box. Mr. Harman, could you spot this question?
Yes, I see this, and it's similar to John Muse's question above, which is about how Nikki's saying if the continuous and the discrete are to be taken as 2 irreducible aspects of reality, how would this impact O as a whole, which is often perhaps mischaracterized as a non-relational philosophy alone? And I saw that John Muse had also said, do I still treat objects as fundamentally discrete, withdrawn, and non-relational, or does this book make me change my position on that? I'm more inclined now to stress the fact that both are equally important aspects of reality. I don't think the philosophy itself has changed, because I've always said, yes, objects are withdrawn and they're disconnected from each other, but somehow they communicate. How do they communicate? And so I've invented this notion of vicarious causation. There has to be a place where discontinuous objects somehow become continuous in order to be able to interact with each other. And if I've made any breakthroughs in this new book, it's mostly terminological ones, where I say that I think the discontinuous has to meet in the continuous and vice versa. That discrete objects must meet in a continuum, right? So that 2 individual physical objects must meet in time and space. which are both continua, and vice versa, two continua must meet in a single discrete object. And then I also extend an idea I've had in previous books, which is that the continuous place where two objects meet is on the interior of a third and larger object that contains both. So I guess, Nikki, my response to your question would be that it is a mischaracterization to say that triple O is a non-relational philosophy alone. That's maybe more a rhetorical device, because the dominant discourse in continental philosophy has been one of continuity, and everything's connected and everything touches. And so triple O's aim has not been to say that everything's disconnected, because if you had that, there would be no causality. Nothing could influence anything else at all. It would be a form of occasionalism. And triple O is not a form of occasionalism. We borrow occasionalist ideas, but I do not say ultimately that God makes everything happen or that the human mind makes everything happen. I think that all actors, all objects can make things happen. And that's because the discontinuity of individual objects is violated at individual points. It's violated by objects forming continua with each other, exchanging their forces in that continuum, and then detaching and going back into their previous discontinuous existence. I wrote an article I published an article back in 2010 called Time, Space, Essence, and Eidos, where I gave this example of two airplanes crashing in midair. And I analyzed that as the two airplanes actually becoming a single object for a certain period of time. That single object then retroactively affecting its pieces, and then the pieces becoming separated from the entirety of the new object, which is the crash object. And this I think, is how causation happens. Two independent things become one thing. They have a retroactive effect on their pieces, and then they disconnect from each other and become separate again, while not being unchanged from what they were before. So you get into some very technical, difficult metaphysical problems at the end. But what this book is more about, this is a book for a broader intellectual audience. Obviously, it's not a technical work of philosophy. I'm trying to show how broad the scope of this problem is for so many different fields, so that nobody can escape it. You may think you're not interested in metaphysics and you just care about history or you just care about science. What I try to show is that this same problem is there at the foundations of all of them. And so there's no escaping it. Just as with any true metaphysical problem, any true ontological problem, there's no hiding place from it. It's everywhere.
Thank you, Professor Harman. Xavier Aranda, he has raised his hand. Xavier Aranda, I would request you to follow.
Yes, thank you. Yes. Hello, Professor Harman. Thank you very much for the presentation. I'm really excited to read about your future book. What I'm wanting to ask you is that, okay, you are taking the idea of the continuous and the discrete, and I have an analogy that I wish to present you. Thinking the continuous as sort of like this framework of legality, and the discrete as a given law. And I think that wouldn't this become an issue because you are kind of opposing the content or let's say the content of a law with the law itself. Let's say that a continuous is like a criteria from which we can understand the discrete, and therefore both cannot be opposed because they are at different levels in this regard. So you could say that's more or less the idea. I don't know if I made myself clear.
Well, if you're talking about the difficulty of explaining the continuous and the discrete in terms of each other, that's also a theme I talk a lot about in the book. You can call it incommensurability. And this is accepted even by the most hardcore rationalists, because, for example, it's a mathematical fact that you cannot take the globe of the Earth and convert it into a map. You can do it, but you can only do it by distorting the size and the shape of the countries. This is why on most maps, Africa looks very small, even though Africa is gigantic. Just try flying across it, as I have tried. It takes forever. Africa is a huge, huge, huge place, whereas Antarctica and Greenland are not nearly as big as they look on maps, or Russia. That has to do with the projections made when you try to switch from a three-dimensional to a two-dimensional depiction of space. I've written a lot about metaphor and how metaphor and literal statement are incommensurable. That if you say, like Homer, the wine dark sea, that is not equivalent to the statement that the Mediterranean Sea is the same color as wine. That's not what it means. That's false and trivial. Instead, Homer is trying to use that supposed qualitative similarity to assert a deeper and more impossible unity between sea and wine in terms of danger and oblivion and depth and mystery. And so literal translations are simply not possible. This is why there will never stop being translations of Shakespeare into French or German or Russian, because no translator is ever going to quite get it right. There are going to be defects and also possibly strange improvements sometimes when you're translating a book. And so incommensurability is a main theme. And for Kuhn, this comes up because he thinks Newton's world and Einstein's world are incommensurable. Not that they're incomparable. You can choose one as being better than another in certain respects. Like we can say that obviously Einstein's theory of gravity explains the motions of Mercury better than Newton's. Einstein's theory predicts black holes, which Newton's could not have, and there's now evidence that black holes exist. And so these things allow us to compare the two theories of physics and say that Einstein's is better. But it doesn't mean that every thing we say or talk about in Newton's or Einstein's theory can be adequately expressed in terms of the other theory. That's why he talks about different worlds. That's why Kuhn compares scientific change to a religious conversion. Everything looks very different once you switch from one theory of physics to another, and there's no going back. You can't unsee a thing after you see it. We can't unsee the idea that mass is curving space and time. We'll never forget that, even if Einstein turns out to be wrong, which at some point he will. So if your question, I think, had something to do with incommensurability, that's how I would answer that part. Did I miss any part of your question?
Well, I was thinking more like when you are pointing out the relations between two particles and the whole idea of space. Space is not like a substance or a subject, but it's just like an abstraction of those relations, right? In that regard, the space will be like this idea of a norm of our law that is not in the same level of a particle that is occupying space. So they are different. So in that regard, I see that there's something troublesome with opposing the discrete and the continuous in this regard.
So your solution would be to say that objects are discrete, but space and time are continua and therefore continuous. Yeah, there's something to that. And of course, I didn't even talk about the wave-particle duality in physics, which is another one of the great examples of the dispute between the continuous and the discrete. The fact that light seems to travel in the form of waves until it's detected by something else, whether a human mind or some inanimate thing. And then we talk about the collapse of the wave function. So now the wave has become a particle of light. And so, yes, by definition, when you're talking about objects, you're talking about discrete realities. And when you're talking about waves, you're talking about the continuous. And it's true that space and time are names we have for the continuous. And that the things that move in space and time are things that we would call discrete. So yeah, I'll concede that point if that's the point you're trying to make. That you can't really define space and time in terms of objects because they are continua. It would be like calling the number line an object. Yes, the number line is an object in a certain sense, right? Because you can compare it to other objects. I can invent the concept of a number line and say, here's a number line. It's different from this desk or this dog. So yes, you can convert it into an object, and yet a number line, just like space and time, functions primarily as a continuum in which other objects are arranged, whether it's numbers or moving physical objects.
Thank you.
Sure. Adriana, would you please put forward your question?
Yes, thank you so much for your talk, Professor Harman. So I'm going to position myself kind of closer in terms of the current and subjective, speculative realism. So I'm sure you are very familiar with the work of Manuel de Landa, and yes. I'm wondering, how do you position your theory to the theory he posed in Intensive Science, obviously with Deleuzian heritage, but I'm wondering if the discrete and the continuous are sort of related to the intensive and the extensive, and the path from the intensive to extensive from the Riemannian geometries to the Euclidean geometry. I'm wondering if the broken symmetries still apply in your theory, or how do you position yourself to that kind of approach?
It's a tough question simply because I haven't gone back to intensive science and virtual philosophy for a while. Delanda and I did do an interview book together, and we remain friendly and write to each other, even in his retirement in Mexico. The main difference, I suppose, comes from the fact that Delanda's background is Deleuzian and mine is Heideggerian, and that means there are certain differences in emphasis. We agree on a lot of things. We're both realists, which is rare in contemporary continental philosophy. There's one thing about the way Delanda defines realism that I would disagree with. Delanda defines realism as the view that there's a world outside the mind. Whereas for me, that grants too much power to the mind. The mind is not the only thing with an outside. So for me, realism is more the idea that no interaction exhausts the terms in the interaction, right? Because even when fire burns cotton, the fire and the cotton are not reducible. The fire is not fully present in that interaction, and the cotton is not fully present in that interaction. So for me, realism is more about the surplus beyond any kind of relation, not just the relation between thought and worlds. Of course, I don't think Delanda would necessarily disagree with that. That's just the difference in emphasis. We also are both very strong believers in emergence. We are strong believers in the idea that you could have a realist social theory, that even though human society was created by humans, that doesn't mean it has a different ontological status from physical particles. That's not an uncontroversial idea because, for instance, Vico, the great Italian philosopher of history, Vico, did draw such a strong distinction. Vico said, we can't understand nature perfectly because we didn't create it, but we did create laws and customs, and therefore we can understand them. Delanda and I would both disagree with that. We would both say that just because you create something doesn't mean you have absolute transparent access to it. Just ask any parent who has a child. The parent can neither understand nor control the child completely. And so the same goes with human society. Yes, you need humans to create the city of Los Angeles, but that doesn't mean any of us can predict what's going to happen with Los Angeles when the Olympics comes here in 3 years or after the next election or whatever happens. Human societies are complex realities that we cannot predict or control. So we agree on that. You asked about some specific things that I'd have to go back to the book and I think and consult it. But I'm very sympathetic to the basic model of Delanda's intensive science book, which is the idea that there are deeper structures, there are attractors that are real, in fact, that are more real often than the specific position of specific particles in space at specific times. Delanda and I are both very much in favor of the approach of Roy Bhaskar, the English philosopher of science of Indian ancestry, who talks about the intransitive realm, that in order to be a realist in the philosophy of science, you have to talk about deeper mechanisms than simply the events that empirically appear to people, right? That an experiment is not just about creating events, it's about revealing the mechanisms that make those events possible. And Delanda does that a lot in his book by talking about deeper structures, topological structures, and attractors. So those are some of the similarities we have. And the differences, I think, are laid out in our book. I'm sorry, I wish the book were fresher in my mind and I could have given you a more detailed point by point.
It's okay. Thank you so much for the answer.
Okay, sure.
Also, you can take another question from Kamil Rajkowski. Kamil, are you here?
Yes, I am. Hello. Thank you, Professor, for the lecture, and thank you for your time. So, I would like to ask you a question about object-oriented philosophy in general. So, in my PhD research, I approach the subject as an object that has a certain proximity to its own withdrawer, or rather, maybe experiences withdrawal within its very existence. So, do you see any conceptual risks in such an approach, or maybe have you ever considered developing object-oriented ontology-based theory that somehow addresses the human as object, as an individual entity?
The human what object? I'm sorry.
Yeah, human as an object. Like, have you
Yeah,
considered that as, for example, like object-oriented anthropology? I'm thinking about this, like this kind of theory that I think it could be like possible way of thinking about human.
yeah, that's probably true, and I can't offer a roadmap for that because being not an anthropologist. But I would say, if you're talking about the withdrawnness of humans, one area where that already happens, of course, is psychoanalysis, which is all about the unconscious. And if the unconscious is a great example of the withdrawn. It's something that is there, it speaks, it has symptoms, but it never becomes fully present. And we can argue about what the unconscious is, but I think that's a very good example of withdrawal. And then in physics, you have the black hole, which is something where you can't know anything directly about what's going on inside. You can make certain deductions about what's going on inside, but that's the extent of it. It doesn't mean you can't say anything about it. One of the criticisms sometimes people throw at me, which I think is a bad one, is negative theology. That if an object is withdrawing, all you're saying is what it's not. Well, that's not really true, though. If you go back to negative theology itself in the Middle Ages, Pseudo-Dionysius is one of the great authors in this tradition. He was originally believed to be Dionysius, the Areopagite, who's a figure who appears in the Bible. It was later determined that it couldn't be him, that it was written much too late. But anyway, Pseudo-Dionysius has a very wonderful passage where he talks about the Trinity. And many atheists, or many Muslims for that matter, since there's no Trinity in Islam, there's only the oneness of God, would simply call the Trinity illogical. And yes, it does look very illogical from the standpoint of logic. How can a thing be both 1 and 3 at the same time? And I'm actually not a believer in the Trinity. But Pseudo-Dionysius gives about as good an argument or analogy for it, I think, as you can possibly give. It's very profound. He says that if you imagine that you enter a house and there's one light, but there's 3 lamps, the 3 lamps are all providing that single light in the house, and you can't tell which part of the light is coming from which lamp. And yet you know there are 3 lamps, but there's only 1 light. That's his analogy for the Trinity. And I think that's a wonderful statement, very helpful in trying to conceptualize how one might think of the Trinity as being something other than purely illogical, even if I'm not personally convinced by it. This is an example of not negative theology, but what I would call metaphorical theology. And I would say that most language involves this sort of non-literal cognition of reality. A good part of my recent work is actually a critique of literalism. And literalism for me is the idea that all you have to do to understand a thing is to make a list of all the properties it has, and then you understand the thing. The philosophical mascot of this idea is David Hume. David Hume, of course, believes there is no such thing as an object. There is no apple. There's just red, round, hard, juicy, cold, and sweet. And we see those qualities together so often that we give them a joint nickname, which is apple, and we assume that there's something holding them all together, even though there's not. There's just a bunch of qualities appearing in the mind simultaneously. And that's spread like a virus through intellectual life, and you'll find people all over the place who are Humeans without knowing it. Even Whitehead in the 20th century, even Franz Brentano in the 19th century, who was Husserl's mentor, believes this. And then Husserl makes one of the great breaks from this. Phenomenology breaks with Hume's preconception because phenomenology says, the blackbird flies through my garden. The blackbird's wings are at different angles every instant of time. The blackbird is in different positions, different distances from me as it flies. And yet I never stop thinking of it as the same blackbird. I say, there it goes, there it flies. It's the same blackbird. Now, this is essentially Aristotle's distinction between substance and accident, risen from the dead. Except that in Aristotle's case, Aristotle would say things like, Socrates can be happy or sad or confused, but he's still Socrates in all of those cases, because Socrates is the substance and happy, sad, or confused are the qualities or maybe the accidents. Aristotle was talking about real things in the real world. Husserl is talking about phenomena that appear to consciousness. So that's the difference. But it's the same logic, this idea that not all qualities of a thing are on the same footing. Some of them are essential, some of them are not essential. So I mentioned that because I'm trying to explain my critique of literalism here. Literalism is the idea that you simply define a thing in terms of the qualities it has. Whereas O, my philosophy, says, no, there is always a tension between an object and its qualities. First of all, because an object's always changing qualities, and we don't call it a different object. If a hair falls off my head, I wouldn't call myself a different object, even though Hume would and Whitehead would. I'd say I'm still the same object, I just have one less hair that fell off. Well, metaphorical language is something I've written a lot about in this context. One of the things I noticed in my 2018 book, Object-Oriented Ontology, is that one of the differences between literal and metaphorical language is that literal language is reversible and metaphorical language is not. So I can say a pen is like a pencil, or I can say a pencil is like a pen. Doesn't matter, because I'm doing the same thing in both cases. I'm trying to show that pens and pencils both have a lot of similar qualities. They're long and they're skinny and they're cheap and they write on paper. But if I say wine dark sea and sea dark wine, those are not reversible. There's an asymmetry there because the two terms play different roles in those metaphors. Wine dark sea is a sea having wine qualities. Sea dark wine would be a wine having sea qualities. So those are two completely different metaphors. And what this points to is the fact that literalism cannot be true. An object is not simply reducible to the sum total of properties that it actually has. And there's other examples where you can see this. I mentioned the case of not being able to project a globe onto a map. That's one kind of incommensurability. But what about the incommensurability in threats? It's an example I like to use a lot. So when the Godfather says, I'm going to make him an offer he can't refuse, that is far more threatening than any specific concrete threat he could make, such as, I'm going to cut off his horse's head and put it in his bed at night when he's sleeping, which is what actually happens in the movie, which is grotesque. The guy wakes up and is screaming because his beautiful horse's head is all bloody and is in his bed. The horse has been decapitated, and it's the mafia that has done this. It's a lot scarier to say, going to make him an offer he can't refuse. Or here's one from politics. Before the first Gulf War, the one in 1990-91 involving Iraq and Kuwait, at the time, there were some rumors that Iraq, Saddam Hussein, was planning to use chemical weapons against American soldiers, illegal under international law. And so Dick Cheney, who was then the American vice president, Secretary of Defense at the time, not yet vice president, Dick Cheney decided to write to the Iraqi government a very sinister letter in which he said, if Iraq uses chemical weapons against the American army, the United States will respond promptly and decisively in a manner from which it will take Iraq centuries to recover. Now that's a threat. It's a nasty, mean thing to say, but it's a very effective threat because it is left vague what exactly he's going to do. If Cheney had said, if Iraq uses chemical weapons, America will use nuclear weapons, that's somehow not as threatening, even though nuclear weapons are very scary. You never want to specify exactly what it is because you're over-literalizing a threat. If you say something like, oh yeah, you'll see, just wait, that's a lot more threatening than specifying a consequence. And that shows, again, the gap between the literal and the non-literal. Or jokes, an example I like using a lot. And one of these days I'm going to have to come up with different examples, but I still like these examples of jokes. One of them being, and this is taken from a survey of jokes that are popular in different countries, there are three kinds of people, those who can count and those who can't. That was very popular in Belgium. Okay, so you see there's an obvious contradiction there. I said there's three kinds of people, but then I only said there's those who can count and those who can't. And the supposed humor of the joke comes from the fact that by making that contradiction, I am inscribing myself into the joke as one of the people who can't count, right? And so if there's a small child there who says, Daddy, I don't get the joke, you have to explain it and say, well, they said there's three kinds, those who can, but then they only said two, those who can count and those who can't. So therefore, the joke teller is one of the people who can't count. Maybe the child now laughs, but the joke is ruined because you've literalized the joke. It's no longer funny. So these are just certain cases of why you cannot shift from the literal to the non-literal register, but I haven't even given you the two best examples yet. One of them is the arts. The arts, I have argued, are not primarily a form of knowledge. For the past 400 years, which are basically the reign of modern physics, right? That's the last 4 centuries have been primarily about modern physics, whether it's in day-to-day improvements, environmental crises, or even nuclear weapons that have been the result of modern physics. Modern physics has been taken as the gold standard of our knowledge of the world. It's in some respects replaced religion as our basic source of knowledge about reality. And in many ways, that's good. However, because of that, the misconception has spread that the hard sciences, modern physics in particular, is the final court of appeal for everything, and should be. And that's clearly not the case. The arts are one example of a very important kind of cognition that cannot be literalized in the way we expect physics to literalize knowledge for us. If you spend an evening, an afternoon at a Cezanne show, a Cezanne retrospective, you might learn some things in terms of knowledge, but it's not primarily a learning experience where you're gaining knowledge about Cezanne. You might learn some things about his life or about his different periods, but you're having a series of aesthetic experiences that you can't really translate into exact prose terminology. As an example of this, imagine you were to buy a Cezanne book and there were no paintings in it. It was all prose. The person is simply trying to describe all of Cezanne's paintings in words, and let's imagine you'd never seen Cezanne's paintings yourself, and so you're trying to imagine what the paintings look like based on the descriptions. You're not going to be able to do that, and you're probably going to be surprised once you actually go and see some paintings. So the arts are one example of a kind of cognition that are not primarily a form of knowledge. But an even more important one for me, of course, is philosophy, philosophia. There has been an attempt in the wake of the scientific revolution to make philosophy more scientific. And you see this even in phenomenology, Husserl. Philosophy is rigorous science, but you see it especially in analytic philosophy, which often likes to call itself exact philosophy or rigorous philosophy. Analytic philosophers love calling themselves rigorous. And what they mean is that they're more scientific than poor, confused continentals like me, right? They are emulating scientific research culture by making incremental progress on frontline research programs and publishing short journal articles and referring only to philosophical advances made in the last 5 or 10 years instead of referring to classics that are centuries old. It's somehow by emulating the culture of the natural sciences and by thinking more logically, philosophy can be made more scientific. I happen to think a scientific philosophy is a horrible idea if it means a literal philosophy. Why? Well, just go back to Socrates and go back to the meaning of the word philosophia. Philosophia means love of wisdom. It doesn't mean wisdom. And you'll notice that even though Socrates is famous in Plato's dialogues for always asking definitions of things, what is love, what is virtue, what is friendship, what is justice, you may have noticed that in none of the Platonic dialogues do we ever get an answer. There's never an answer where Socrates says, hey, we figured out what justice is. Is that because Socrates is simply ironic or Socrates is incompetent? No, it's because you can't define a thing in that way. A thing is incommensurable with any definition of it. Socrates knew this. Philosophia, the word itself, knows that. Aristotle said this in the Metaphysics, that you can't define a thing because a thing is concrete, but a definition is made of universals. So if I describe Slavoj Žižek as a funny philosopher, well, there are lots of philosophers and there are lots of funny people. Even if I call Slavoj Žižek a funny Slovenian philosopher, again, there's going to be other funny philosophers who are Slovenian. You're never going to be able to come up with enough adjectives that sufficiently describe Žižek to differentiate him from other things that exist. Žižek is simply Žižek. He's a concrete individual, and any attempt to define or describe him is always going to fall short in some way. And so these are some of the reasons that I don't support literalism in any fields. Obviously, literalism is going to be much more useful in mathematics, where it's practically the method. You define a thing and you unpack all of its properties. Works pretty well in mathematics. And to some extent in physics, although you can't always do it in physics because you've got things like the conflict between quantum theory and general relativity. A literal definition of both those fields brings them into conflict so that science is at an impasse. And we're going to need another revolution. And as Kuhn points out, scientific revolutions have something of the poetic or religious character about them. You can never fully define all the aspects of a paradigm. Right? That someone working in Einstein's paradigm as a researcher into gravity cannot give you a sufficient list of all the criteria it takes to be an Einsteinian. It's just kind of a general sense. And we know certain things. If someone doesn't think mass curves space and time, then they're not working in Einstein's tradition. What if someone doesn't believe in black holes? Well, that's a closer call. I became involved with a group of physicists in Cairo who don't believe in black holes. And these are very sophisticated, cutting-edge physicists at the University of Cairo who think that black holes are a misinterpretation of general relativity. But you'd still call them Einsteinians. So it's sometimes hard to know what's an essential hard part of the core of a scientific theory and what's a more optional thing. So in other words, it's another way of saying that it's impossible even to literalize the sciences, let alone philosophy, the arts, and so forth. Now, you got me excited there, and so I may have gotten away from your main question, which is about anthropology and whether you could have an object-oriented method in different fields. In principle, yes. And I tried to do this for social objects with my book Immaterialism. I tried to show what an object-oriented social theory would look like it looks like a theory where you're not just focusing on the events a thing is involved with, and you're not just focusing on the origins of a thing, but you're focusing on a series of irreversible transformations that it goes through by forming symbioses with other objects. So in the case of the Dutch East India Company, for instance, I wrote that around 1650, it turns out that the Dutch East India Company realized they were making more money on trading inside Asia than they were on trading back with Amsterdam. And so they decided to focus on becoming an Asian company instead of sending all their shipments from Indonesia back to Amsterdam, which took a long time. And if they're going to focus on Asian trade, it meant that they needed shallower ships because a lot of the Asian ports are on rivers. The water is not as deep. And so they couldn't have these giant ocean-going vessels that the Dutch loved to build in their heyday. You needed these smaller ships that don't displace as much water. And initially, they had to hijack those from the Chinese because the Dutch didn't know how to build them. After a while, they figured out how to build them themselves and didn't have to keep stealing the Chinese ships. And this enabled the Dutch East India Company to basically become a local Asian power, even though it was of European origin. It was Dutch people living in what is now Indonesia. They essentially became an Asian power. That was irreversible. Just as when they finally captured the Northern Strait near Singapore, that's irreversible because it allowed them to unify the old Chinese and Arab trade routes, making it a very different sort of company from what it was. In the case of the history of the United States, the Civil War was surely one of these symbiotic moments. It not only ended slavery, but it ended the previous conception of states' rights, and that conflict has never fully gone away. I mean, the Republican Party has long been championing states' rights, at least since the 1960s, but it was still a turning point. Trump, unfortunately, may turn out to be another sort of turning point. The United States may not be what it was before after Trump. We'll have to see. But that's one way that I tried to apply object-oriented ontology to one of the social sciences. And I've got other ideas for doing that. I've tried to do it with architecture. Anytime someone in another field asks a question like this, usually good things happen because usually I end up writing a book based on that question and I learn something. So I've got my architecture book. I've got my art book. I've got one on archaeology that I wrote with Christopher Whitmore, and we're going to do another one together about human transformation. It's going to be called anthropoiesis. How were humans irreversibly... I should have mentioned this in response to your question. Chris is an archaeologist focusing on ancient Greece at Texas Tech. We've done this one book together, Objects Untimely. The second book is in its early stages. We're going to talk about which inventions irreversibly transform humans. And there's some obvious ones, right? Even the domestication of dogs, city walls, certain weapons. Artificial intelligence is one that's coming, that's going to irreversibly transform us in certain ways. I'll tell you my favorite fact from the history of anthropology, and I can't give you exact dates on this, but this fascinated me. This insight that humans knew how to use fire many thousands of years before humans knew how to create fire. It's something I had never thought about. So, in other words, at first, humans had to accidentally find fire. Oh, there was a lightning strike. The forest is on fire. Let's take some of that fire and take it home and keep it going because we don't know how to make it. Fire is just something that appears in nature, so we have to keep it burning and burning. This is the hearth keeper type, right? The person who keeps the fire burning and burning, because if it goes out, you're in trouble. You no longer have anything to cook with. Eventually, humans figured out how to create fire from scratch, and now that's a very basic technique. I might even be able to do it if I can remember Cub Scout memories. I might be able to create a fire if I'm stuck in the forest. Maybe, maybe not, but I at least would have a chance of doing it. But for many thousands of years, humans had no idea. That's one fascinating fact. Another one that was turned up from the archaeological evidence that I would love to shed some triple low light on is that apparently dogs were domesticated twice. Dogs were domesticated and found to be very useful, and then humans kind of gave up on dogs and then domesticated them again later. I'd love to hear some theory of why we gave up on dogs, and then the second time we didn't. They're still with us. But anyway, that was a little off track. But the point being that I find stimulus in encountering other fields and having people ask me, what would a triple O theory of such and such look like? And at first, I always answer from a position of complete ignorance because I don't know. I didn't know the first thing about architecture when I started, but now I could kind of give you a decent half-hour talk off the top of my head about triple O and architecture, what the implications are for architecture. You just need to do enough research in a field and think about things enough and maybe find the right collaborators. So if you ever want to write a triple O anthropology thing, I'll be happy to join in and we can come up with an article together and see where it goes. Love to see what you come up with.
Thank you very much, Professor. And I would like to ask you a question. Can I contact you via email with some more questions?
You can. And You can, and since I had to put my email address here in the chat window, anybody else can do that. I would just offer the caution that I'm not as fast as I used to be because I've gotten very bad at managing workflow. I'm trying to start saying no to things more often and quit things more often. But I'm not, I used to be, especially before I was married, I would answer emails in 5 or 10 minutes. That's no longer possible. I've got to budget time for these things, and it may take a few weeks. I'm sorry about that, but I'll do my best.
That's not a problem, but thank you very much. Thank you very much.
Sure, that's good.
Thank you.
Yeah. And if I don't answer your email, just send a reminder. It means I lost it in my inbox. Doesn't mean I'm angry at you or anything. Oops. And yes, you may find some people who interpret that away, but primarily there are jumps in nature. I know Leibniz says that there aren't, but Leibniz was a pre-quantum theory figure. So it's less about disregarding than about realizing that there's a debate about these matters, and that light does behave as particles. It's not just about waves. The duality is real. In fact, Richard Feynman at one point flirts with saying that light simply is particles, not particles and waves. But you can't simply explain the quantum aspects of nature away. If you could do that, then we could have everything be reducible to Einstein's gradualism, Einstein's continua. And we can't do that. Did the meeting end? I'm not hearing anyone else.
Yes, Professor. Would you like to take any more questions? I think you are on a very tight and hectic schedule. Do you have time?
I am. I'll take a couple more questions. Yeah, I am on a tight schedule today.
Yes, there are a few in the chat box.
Okay. Let me scroll up and see. Oh, Mac asks, Doctor, what do you have to say on relational ontology? Obviously, things relate to each other. I've been a critic of relational ontology to the extent that it tries to say everything is relational. Let's take Bruno Latour, for example, close friend of mine during his lifetime. Bruno Latour was very explicit in saying a thing is nothing more than whatever it transforms, modifies, perturbs, or creates. So he calls objects actors because an object is nothing more than its actors. Than its actions. He's not the first to say that. Whitehead said something like that. American pragmatism said something like that. The Megarians in ancient philosophy said something like that. The Megarians who are argued with in Aristotle's metaphysics. The Megarians who came from Megara near Athens. It's a small city that is still there in Greece today. The Megarians were complete actualists. They believe that a thing is only whatever it's actually doing right now. So a thing is its relations. A thing is its effects on other things. A house builder is only a house builder if they are building a house in this very moment. Aristotle's objection to that is the same objection I would make, which is that what about a house builder who goes to sleep? Are they not a house builder at all because they're not building right now? And if that's the case, then how is it that when they wake up, they know how to build a house again? So Aristotle's point is there must be something called the house building skill that exists even when it is not actually being exercised, even when it is not currently in relation to anything else. The house building skill is somehow inscribed in the house builder in some vague way that we don't understand. And so they can go to sleep and then they can wake up, and whether they're building or not, they're still a house builder. Whereas if I start building a house, even if I'm doing it actively, it's not really house building. It's going to be some incompetent failure because I have no idea how to build a house. I'm not even that good with tools. You need to be able to explain what Aristotle calls potentiality. Now, there's another problem with potentiality, which is that it's kind of lazy. It simply allows you to defer a question to the future. So if I can say that an acorn is a potential oak tree, okay, we all agree with that. But then you're off the hook of having to explain what are all the actual steps by which an acorn turns into an oak tree. And this is why Latour, for example, does not like the notion of potential. But you're going to need something like that. You're going to need some way of talking about a capacity or an ability that is not currently expressed in things. And yes, analytic philosophy is having all sorts of debates about capacity metaphysics these days. But when it comes to relational ontology, my main worry about it is that if everything were nothing more than its current relations, there's no reason why anything would ever change. Because everything is, if I am nothing more than all of my relations to everything in the universe right now, why would I enter into new relations in the future? I should be totally self-sufficient as I am. So I hope that makes sense as an answer. There was a question here about Kant from Mahendra Singh. According to Immanuel Kant, men always exist in phenomena because he cannot reach noumena. Then how the triple O is relating to the unconscious thing in the noumena. Okay, that's a good question. The answer is that I largely accept the Kantian noumena. I think that Kant was onto something there. I don't think we can get around that. And I think we can talk about noumena indirectly, whether through metaphor or innuendo or hint or analogy. There are many different ways to do this. And I certainly didn't invent them all. These have been around since antiquity. Where I disagree with Kant's noumena is that noumena for Kant are something that haunts the human mind alone. We poor humans are stuck in this mind where we can't see the noumena. Oh, woe is us. I extend the noumenal to inanimate interactions between non-human things. So when fire burns cotton, there's also something noumenal going on there. Even though I personally don't think the fire and the cotton are conscious, people sometimes think triple O is panpsychist. It's not. I think a lot more things are probably conscious than we realize, but I don't think everything is necessarily conscious. But I do think even if fire and cotton are not conscious, there is something noumenal going on because the fire is only dealing with the phenomenal cotton. The fire is burning the parts of the cotton that the fire is capable of interacting with. But a fire is not capable of interacting with lots of aspects of the cotton, such as the smell, the color, the price. So for me, the noumena are everywhere. They're not just something that make human beings finite. The noumena make everything finite. I hope that helps. That's the main difference between triple O and the main Kantian tradition, is that I don't think we're just talking about the thought world relation. I think we're talking about any relation at all in philosophy. There's now a question from Hamza. Lajrud, could you please explain how triple O in your conception of realism would contend with Donald Hoffman's The Interface Theory of Perception? Very interesting. I actually did a talk on the internet with Donald Hoffman, and we had a very nice discussion. I found him very congenial. We had a lot in common. I think the main difference between me and Donald Hoffman is that Hoffman's interface theory of perception also believes that we can't get at the world the way it really is, because just as with Kant, we're equipped with a certain human cognitive set of implements, and that's how we interpret the world. We don't interpret the world directly, but we interpret it through our human interface. The main difference, I think, is that Hoffman grounds his theory very much in a Darwinian theory that evolution has made us this way, that evolution has ensured that we only can perceive things in certain limited ways. Whereas I don't think it has to be the result of evolution. I think even if God created humans directly to perceive the world, there would still be the same problem, because God would still have to create us with human cognition rather than dog cognition or mosquito cognition. Maybe God could create a creature directly with even more perceptual abilities than the ones that exist, but it's never going to be infinite, right? It would have to be finite, unless humans would become gods themselves in this example, which would be blasphemous for most religions. But so that's the main difference I have with Hoffman. I think very highly of his work, but I wouldn't ground it all in Darwinian evolution the way he does. I think that's all for the questions. Maybe that's it. It's been 2 hours almost. Since the book is coming out, I have another podcast to do shortly about the book. So everyone wants to talk to me right before the book comes out, which I guess is a good idea. That's why it's a busy day. Final Saturday before publication.
Yes. So I think there is no more question left, and I would request Balaram to conclude this session with vote of thanks.
Thank you, Professor, for your wonderful talk. Hello and good evening, everyone. I'm Balaram Balo, Senior Research Fellow at the Department of English, University of Kulani. As an Executive Editor of Entanglements, Journal of Post-Humanities, it is indeed a privilege to have been asked to propose the vote of thanks to this talk. And on behalf of Entanglements, Journal of Post-Humanities, and Indian Post-Humanist Collective, IPC, I extend my heartfelt gratitude to everyone who made this special talk possible today. And we are very grateful to Professor Graham Harman for delivering this special talk on his forthcoming book, Waves and Stone, on the ultimate nature of reality and enlightening us with new insights into our conception of reality and materiality. A special thanks to our organizing committee for their dedication and tireless efforts in making this talk happen seamlessly. Our sincere appreciation also goes to Dr. Shukhendu Das, Assistant Professor of English, Bankura University, and Editor-in-Chief of Entanglements, and the Chief Architecture behind Indian Post-Humanist Collective for taking this initiative. To our wonderful audience, thanks for your participation and thanks for your patience, and warm response. Your encouragement is actually driving force behind all our endeavors, and your engagement, your encouragement means a lot to us. With this, we hope to carry our learning or carry out today's learning in our next understanding of or in our next thinking of things or thinking with things. And we look forward to meeting you all again at our next event. Thank you once again, and have a nice time. Good night, everyone. Thank you.
Thank you.
Thank you, Professor Harman. Have a nice day.
All right. All right. You too. Appreciate it.